Here we are at our 8.7 set of notes. Here we're looking at the volume of spheres. Now, the volume of a sphere can actually be found based upon this equation, V equals 4/3 pi r cubed. And don't let the fractions and the r cubes intimidate you. Pretty much once you start working with it, usually students are like, oh, okay, it's kind of just a plug and chug, kind of like with cylinders. And half of a cylinder, or I'm sorry, half of a sphere is called a hemisphere. So just kind of think about the United, or no, the globe, and how you have like the northern hemisphere and the southern hemisphere. So that would be half of that. All right. And so how we actually come across this is if you have a cylinder and a sphere and they actually happen to have the exact same radius and the same height, so kind of very special circumstances for this to occur, but this is what kind of forms the sphere. Then they would have 2 times the radius. So imagine here's your cylinder and it's got some height to it. Well, imagine a sphere as well, kind of like having the same height. Well, its radius would be twice. So, like there, for example, is a radius, but it would be 2 times that radius to kind of get that equivalent height there. And then as a result, too, for a sphere, it's always going to be 2/3 the volume of a cylinder. Okay. And so this is actually useful for how we actually create then the volume for a sphere. And here's kind of the proof of it. So imagine you have the volume for a cylinder is pi r squared h, that we know. And instead of h, we're like, hey, we don't want a cylinder. We just want a sphere here. And so that's where this 2r comes from, because again, that's kind of acting as the height. And then we always multiply it by 2/3 of the value, because imagine the sphere kind of fitting inside of here, right? Well, you have this other volume that you're not really accounting for. And so that's where that kind of like 2/3 of that cylinder comes from, because you're kind of like losing some of that volume there. And so it's always going to be 2/3 of that cylinder. And as a result, if we kind of clean it up a little bit, well, again, this is 2r times the 2 on top. This is really 2r over 1. So 2r times, or 2 times the 2 on top would give you the 4. And then the 3 times the 1 gives you the 3 on the bottom. And then our r squared and r come together. And when we multiply with like bases, we add the exponent. So that's where that r cubed comes from. Okay. So again, that's just like a very fast, quick proof. You don't necessarily have to memorize that proof for me, but uh, it is kind of just nice to see where that thing comes from. Now, again, we're going to actually see it in action. And we're going to use, I'm not actually a big fan of 3.14. You can use 3.14, but I prefer pi, just because it's a very exact answer then. So we have a sphere here, and then the radius is 3. Now the formula, I always encourage my guys to just simply write out the formula, just because it is a little bit different than the others. So 4/3 pi r cubed for a sphere. And now we're going to go ahead and plug those values in. And so when we plug those values in, we end up with V equals 4/3 pi times our radius is 3 cubed. And then we're going to clean this guy up a little bit. So we have 4/3 pi. 3 cubed comes out to be 27. And now how you would enter this in the calculator, or rather I should say, 4 times 27 comes out to be 108 divided by 3. So 108 divided by 3, which would then give us 36 pi. Okay. So again, we multiply the 4 times the 3, or the 4 times the 27 rather, and then we divide that by 3. And when you do that, you get 36 pi. Now, how you enter this into a calculator, let's say you kind of just want to go straight from this guy, the 4/3 pi times 27, to just maybe a decimal value. Well, how you would enter that is open parentheses 4 pi times 27 And then we're going to close that parenthesis because what we're doing is we're telling our calculator, hey, here is a set on top as the numerator. And then we're going to click the division key, which creates that fraction that we want. And then open parenthesis, 3, close parenthesis. And then when we enter that, we end up with 113.1 for that spherical volume. Okay. But again, parentheses are very massive. Okay. Now on this one, we don't actually have a unit, so we're just going to kind of keep it as that. All right. Let's go ahead and see another one together. So for this one, number 2, we have the formula V equals 4/3 pi r cubed for the volume of a sphere. Well, in this situation, we're actually given the diameter though. And so we know that we have to actually cut this in half. And so the radius is actually not 12, but 6. And now what we can do is go ahead and plug it in and kind of see what we get. So we have V equals 4/3 pi times our 6 cubed. And then V equals, kind of cleaning this up a little bit, we have 4/3 pi. 6 cubed comes out to be 216. And then when we multiply the 216 times the 4, and then divide that by 3, we'll end up with an exact value of 288 pi. So again, in the calculator, it would be 4 times 216 divided by 3. And that's how we get that 288 pi. And that would come out to be 904.8. Okay. Go ahead, feel free to pause the video if you have any questions on 1 or 2. All right, now what I'd love for you guys to do is to pause the video, give 3 a fair shot, and give it a fair try. All right, and here it is, number 3. So we notice that we end up with the 4 times the 125, which would give us 500. And then that's not cleanly divisible by 3, so that would be your exact answer, the 500 over 3 pi. And then as a decimal, when we just multiply it by pi, we get 523.6. All right, let's go ahead then and move on to example 4, 5, and 6. So here we have a diameter of 13. And so as a result, we need the radius from that. So we're going to cut that in half, and our radius is 7.5. Again, our volume for a sphere is V equals 4/3 pi r cubed. And we're going to go ahead and place in our values. So V equals 4/3 pi times the radius is 7.5 cubed. And so now when we cube this value, we end up with V equals 4/3 pi times 7.5 cubed comes out to be 421.875. And we'll go ahead and multiply that by our numerator, 4. And so we end up with V equals 1,687.5. Now this is still divided by 3 pi. And so in the end, it will come out to be V equals 562.5 pi. Now again, that's our exact value. And so we're just going to multiply that by our pi to then get 1,767.1. Okay. All right, what I would love for you guys to do is to pause the video and try out 5 and 6. And here are our results for 5 and 6. Now, I know it said to just kind of like leave your solutions in terms of pi, but generally, if you convert to just the decimal value, then you can kind of cover other answers too. So I personally like that extra step. So yeah, for number 5, we got 2,304 pi with that decimal value. And then for number 6, we got 1,072.476 pi with that decimal value. Go ahead, feel free to pause the video if you have any questions at all. All right, so we've been doing a lot of different spheres, right? Finding volumes of spheres. So now, questions 7 through 9 kind of bring it up just a little bit, but not by much. So hemisphere now. A hemisphere, keep in mind, is half of a sphere. And it says that it has a radius of 7 inches. So find the volume of a hemisphere. Well, what I'd love for you guys to do is pause the video, give it a shot, and see what you guys come up with, and then we'll see what we end up with in the end. All right, so let's see this guy in action. So keep in mind, a hemisphere is 1/2 of a sphere. And so the volume for a full sphere is 4/3 pi r cubed. And we know our radius is 7. And so what we're going to go ahead and do is plug in our values. So we end up with V equals 4/3 pi times our radius here is 7 cubed. Now we're going to go ahead and cube our values. We have 4/3 pi. 7 cubed comes out to be 343. And now we're going to go ahead and multiply the 4 and the 343 together. And when we do that, we end up with 1,372 over 3 pi. And in turn, then that would come out to be V equals 1,436.8 as like the decimal value. And we're going to now divide this by 2. Because we're talking about strictly a hemisphere. Okay. And so when we do that, we have 686 over 3 pi, or 718.4. Now, because we're dividing it by 2, you can approach this one of 2 ways. Noticing that our numerator is an even number, you could just divide the top number by 2, and then that's how we got the 686. Or if you wanted to, you could also, because you're dividing by 2, it'd be essentially times 2 on the bottom because you're dividing it by 2 down there. And so it'd be like 1,372 over 6 instead. But then that's just kind of extra work. So I would almost, because it's even, you can kind of get away with this where you just kind of divide the top number by 2. If it's not, though, this is kind of a safer path. Because say it's even, prime example. Or I'm sorry, odd rather. So yeah, those are our solutions. Again, this is a hemisphere, so you have to cut it in half at the end there. Okay, go ahead. Feel free to pause the video if you have any questions on 7. Now we're going to go ahead and look at number 8. It says a sphere has the volume of 288 pi inches cubed. And so we're asked, oh, speaking of which, this should be inches cubed. Make sure we have those labels. So again, for number 8, 288 pi inches cubed for that volume. And we have to find the radius that we don't know for the sphere. So our volume equation is 4/3 pi r cubed. We're talking about just a normal cube, not a hemisphere this time. So just normal sphere. Did I say cube? I meant sphere. All right. So now we know the volume is 288 pi, so we can go ahead and plug that in. We have 288 pi equals 4/3. I'm going to give myself just a little bit of space out in that in front of the 4/3 pi r cubed. And right now we don't know what the radius is. Now what we can go ahead and do is kind of like the cone. We're going to multiply both sides by 3. Okay. And we can also at the same time divide that by 4. We call that the reciprocal. Okay. So we're multiplying it by this guy's reciprocal. So essentially just flipping the numbers. And we're doing that to both sides. Now, when we do that, these 3's are going to cancel. These 4's are going to cancel, one on top, one on bottom. And so the only thing we're left with on the right side is the pi r cubed part. Now on the left side, when we do our 3 times 288, and then we divide that by 4, we get 216 pi over there. Next, we're going to try and get this r all alone. Well, we kind of have this pi, which is acting as a constant right next to it. So we're going to divide both sides by pi on both sides, kind of just get rid of it. And so pi's are going to cancel on the right side. We have r cubed over there. And on the left side, the pi's are also going to cancel, leaving us the 216. Now, lastly, what we have to do is take not the square root, but the cube root of both sides, because we're talking about r cubed, not r squared. So we have to take the cube root. Looks a lot like the square root, but we got this little 3 in front. And we're doing that to both sides. Now what happens is this cube root cancels with this little 3, and then r is all alone and is equal to something. Now, how to find this value is you have to think of a number that when you multiply it by itself and then multiply it by itself again, you get 216. And so the value that does that is 6. So if I were to take 6 times 6 times 6, I would get my 216. So kind of reversing that, that's how we get this value of 6. All right, so there is our R value. Now, it is asked, and it's a great question. It's often asked, well, Mr. B, how do you find something where it's not like so clean? And so in class, I was like, okay, great question. Let's talk about maybe like a number, you kind of do all this math, yay, math, yay. You do all that math, right? But then you're getting to this point where you're like, okay, I've got r cubed is equal to 240, right? So I'm like there, and I know that I have to take the cube root, just like we did a moment ago. So this is just a side question, just so you can kind of see it in action. So we take the cube root of both sides. And then the cube root comes together with the cube, just like we saw a moment ago on the other one. We have r by itself. Now, think about a number that when you multiply it by itself times itself again, you get 240. Well, unfortunately, there isn't anything. Now, there's some other math that like Algebra 2 gets into and pre-calc dive into, but we're not going to get into that because that's kind of their deal. Instead, what I'm going to show you is how to actually find this in the calculator. So what you need to do is this 240 is acting as the base. Okay, so this guy's your base. So we need to open up a parenthesis. Okay, in your calculator, open up a parenthesis. Then you're going to type your base in, 240. And then we're going to close the parenthesis. And then we're going to caret, the caret symbol for the exponent. So right now your calculator is like, okay, great. I've got my base of 240 and I'm raising it to some exponent. That's what your calculator knows so far. Then we're going to open another parenthesis. And then this cube root thing kicks in, and that is we're going to type 1 divided by 3 because we're doing the cube root. And then we're going to close parenthesis. And when we enter that, you get your answer. Okay. And so when we do that, we end up with R coming out to be 6.2 roughly. So just roughly about 6.2, right? Now let's compare our two answers. Again, this was just a completely side question. So you kind of ran through all the math, and then you do this cube root stuff at the end. Now let's compare our two. Well, earlier, dealing with the volume, it had like something like 216, which was a smaller number than 240. Well, then it would make sense that our radius was smaller than the one with 240. Okay, so our kind of answers check out there. All right, but that is in the calculator how you would do it. You would enter your base, caret 1 divided by your root that you're doing. In this case, we're doing a third root. In the future, it might be like a fourth root or a fifth root. Usually, we don't go too crazy. We start then mixing it up with like 2/5 and other areas. All right, what I would love for you guys to do now is to pause the video, really seriously give number 9 a fair shot. Like try it on your own, see if you can do it all the way on your own. And then we'll come back together and then we'll see how we did. All right, let's see this in action. We have the volume for a sphere is 4/3 pi r cubed. Well, we know the volume. It is 972 pi equals 4/3 pi r cubed. I'm going to show it slightly a different way this time, and you can kind of choose whichever method you prefer. The downside is this requires one extra step, but it may help some people out. So we're going to multiply both sides by 3. Boom, boom, that cancels. So then 972 times our 3 would give us 2,916, which is equal to 4 pi r cubed. And then we'll divide both sides. We can actually divide both sides by 4 pi on this one. Let's go for that. Because they're both acting as a constant. So 2,916 divided by 4 pi. Just keep in mind that this is in a parenthesis and this is in a parenthesis. By we end up with this crazy weird decimal. 232. I'm just going to write this really long one. 0479070279834. So as long as I can go to get the most exact answer, equals r cubed. And then we'll go ahead and take the cube root of both sides. We're going to take the cube root of both sides. So this is where that calculator really does come in handy. You would open up the parenthesis, type in this huge number. So I'm just going to put the huge number. You can type that in. And then caret, and then open parenthesis 1 divided by 3. Close parenthesis. Okay. And so when we do that, our radius comes to about 6.1. Now, again, you could do further decimals, but for me, for right now, that's fine. Okay, so there is our radius. Go ahead, feel free to pause the video if you have any questions at all. Oh, never mind, guys. I just noticed, might be, please forgive me. I noticed that it does actually have the pi. So we gotta scoot back. I was like, this doesn't seem quite right for a moment. Please forgive me on that. The process is still the same though. Okay. I do sincerely apologize. I did not see the pi that they gave us. Sometimes they don't do that. So this has pi. And then what would have happened is the pi's would have canceled. Okay. So really we have two 916 divided by just 4. So 2916 divided by 4. We get 729. I'm like, I thought this one came out clean. But and then lastly, we're going to go ahead and take the cube root of both sides. So the cube root comes together, cancels with the cube. R is all alone. And then that equals 9 in the end. So our radius comes out to a clean 9. Okay. Go ahead, feel free to pause the video. Again, guys, I did not see that pi given. So thank you for your patience on that one. All right. Lastly, we have a cylinder, a cone, and a sphere all have a radius of 3 feet and a height of 6 feet. And we're asked to find the volume and record it on the table. So guys, this is just an awesome summary of each one. I want you to go ahead and pause the video, find the cylinder, the cone, and the sphere. And then what I want you to do is look at those questions and see how do they kind of relate with one another? Like how does the sphere relate with a cylinder and how does it with a cone? And obviously greatest to least. So go ahead, please give 10 a shot and then we'll come back together. All right, and so for number 10, we noticed that for our cylinder, pi r squared times height, the radius and height were given, we got 54 pi. The cone we know is really just a third of that. So we just divide that by 3 and we get 18 pi. And then for our sphere, here's the math for that. Again, our radius was 3. 4/3 pi r cubed. And then we multiplied here the 4 and the 7 to get the 108 divided by 3, which then simplified down to 36 pi. So now, what is the relationship between the sphere and the cylinder? Well, again, earlier in the definition, we said that a sphere is 2/3 of a cylinder from that definition. And so that's why we're even seeing, based upon the calculations, that the sphere is 2/3 of the cylinder. So 36 pi is actually 2/3 of the 54 pi. And the sphere is also, notice, between the cone and the sphere, it is actually double. So I just really like times 2 and I can get my sphere's volume. And then from the the greatest to the least capacity, well, cylinder is going to hold the most. It's got 54 pi, sphere is second, and then finally cone is last. I'll go ahead and let you guys summarize today's lesson, especially kind of honing in on the sphere. Pretty powerful, volume and item defined. And then we'll come back together really fast for one last quick question. Okay, one small, I wouldn't even say challenge question, but it does use what we call composite shapes. And what I want for you guys to do is draw a cylinder. So we have a cylinder, and we're going to have this cylinder have a height of 7. Okay, we'll leave units out of it for now. And then think about this being a grain holder storage, like a grain silo. Generally, you see them with this top that's like a hemisphere. And we're going to say that the radius is 3. So what I want you guys to do is find the volume of how much grain could actually fit inside of this. All right, so for our cylinder part, we should have gotten 63 pi. For our sphere part, just a full sphere, again, 4/3 pi r cubed. We dump in our radius. We get 108 over 3 pi. And then that comes out to be 36 pi. Now, this is a full sphere, right? So we need to cut this sphere in half to become the hemisphere at the top that we need. And so that would yield us 18 pi. Okay, so just be careful of the hemisphere part. That kind of gets some students. And then finally, we just need to add those items together. So 63 pi plus the 18 pi would give us 81 pi. So that would be your volume for this grain cylinder or this grain storage container. Okay. And then if you multiply that by, the pi, you get 254.5. Okay. So again, I just wanted to give you guys kind of like a preview of, yes, there are these things called composite figures. So it's like taking the two items together and then you combine them. Another popular one that I've seen, we don't actually have to run through the motions of it, but another very good question would be like, hey, when you go, if you play tennis, they sell those tennis balls, and then you know how you have like usually three balls in there, where they give you the radius. So maybe the radius is like, I don't know, we'll go with 4 just to mix up some numbers, and then the height of this thing is, we'll go with 20 just to mix it up. Actually, no, it can't be 20. Actually, yeah, I think on this one, what I did with former students was I literally just gave them a radius. Yeah, I just gave them that. And then they had to figure out how much volume is like just the air, on the sides. Okay, so great question. You can find, for the tennis balls themselves, but really I kind of wanted like, okay, what's left over just based on the air. All right. So if you want to try that one, please feel free. Go ahead, give it a shot. Um, but yeah, just a great application for those guys who play sports and tennis. So, all right, guys. So that is our 8.7 set of notes.